Let's revisit the number representation that we looked at earlier. If you observe, I have added a few more entries to my table. Before I had a few languages. Now, this was the object. It was represented by different ways. Now, I'm creating essentially another number representation, this base 3 or base 4 representation. And in that case, these numbers would be something like in this column. This object that was called 3 would now be called 1, 0. The object that was called 7 will now be called 2, 1. Now we have new representation of numbers, and whatever we can do with numbers, we can do with in this new representation as well. So let's try to see one example of it. So if I think about addition, the fact of addition is like what is given here. Now we can represent this if as 3 plus 4 is equal to 7, and some more ways, and some more ways. Now this is something we saw at the beginning of this module. Now that we introduced this different bases, we can do arithmetic in those bases as well. So let's say if I'm going to do arithmetic in base 3 or 4. So here is a factual statement. It is this object plus this object is equal to this object. If I'm going to write this in base 3, and you can go look at the table that I had a couple of slides back. In base 3, this object was represented by this was represented by this was represented by this. In base 4, it would look something like this. Once again, in base 4, this object is represented by this object is represented by this, and this object is represented by this. Let's look at one more fact. So here I have this object plus this object is equal to this object. In base 3, this object is represented by 1, 1. This object is represented by 2. This object is represented by 2, 0. Here's another example. We have this object plus this object is this. In base 4, it will be represented like this. Let's try to define addition, and let's look at how we define addition in base 10. To define addition in base 10, I needed to do something like the value of I plus j when I and j are less than 10. So it would be things like I needed to know what is 3 plus 4, 6 plus 8, and so on. And once I knew that, I can build on top of that addition of arbitrary decimal numbers. So let's try to do this with base 5. In base 5, we need to know the value of I plus j when both of them are less than 5. Things like 3 plus 4, 0 plus 3, etc., etc. So if I look at this one entry, say here I'm adding this object, which was 2, with this object, which was also 2, that gave me this object 4. If I had this object and I added this object to it, that was 4 plus 1, and that means I got an object that was represented by this. Once we have this, we can do other problems such as things like 223 plus 234, etc. So let's try to do this problem. I would like to know what is 234 plus 34 in base 5. So what am I going to do? I'm going to look at 4 plus 4. So this is my object 4, this is my object 4. Addition gives me this 1, 3. So I'm going to write the number 3. And that will give me a carry of 1. So then I'm going to have 3 plus 1, 4, 4 plus 3, 7. 7 in base 5 is going to be represented as 1, 2. And you can see one example where this shows up is this 4 plus 3 is 7, and that's represented by 1, 2. So I'm going to write 2, carry is 1, and that will give me 2 plus 1 is 3. This will be the answer in base 5. Now we can do the same thing with multiplication. This will require a little bit of more effort. So here we have a multiplication table filled in, and what I have is, let's look at one particular entry in here. Let's say I have 4 times 3, that is 12. 12 is going to be 2 times 5 plus 2, and therefore it is going to be represented by this 2, 2. If I look at something like this, it's going to be 2 times 4, that's 8, and that is going to be 1 times 5 plus 3, and that's why it's represented as 1, 3. Let's look at how we can do multiplication in base 5. Now this is a little bit more challenging than addition, just like how multiplication even in base 10 is more challenging than addition. So what do I have? 4 times 4, that's 16. That is 31, which is over here. So it's going to be 631. So I'm going to write a 1. The carry is going to be 3. Then I'm going to do 4 times 3. So 4 times 3, that's 22. Plus 3. Now I have to be careful. I'm doing addition in base 5. And that's why this is going to be 2 plus 3 is 5, which is 0, and is going to be 3, 0. Now, I find this pretty challenging to do. I think you might find it challenging to do as well. So what I'm going to do is I'm going to do all the arithmetic in base 10 first. So it's going to be 4 times 3 is 12, plus 3, that is going to be 15. And if I were to convert 15 to base 5, it will be 3 times 5 plus 0. So I'm going to write a 0. The carry is going to be 3. 4 times 2 is 8. 8 plus 3 is 11. 11 when I mapped will be 2, 1. Now I'm going to add a 0 here, just like what I would do in a decimal multiplication. Then I'm going to do 3 times 4, that's 12. Let me clear up a little bit of space here. Okay, so 3 times 4 is 12. So 12 that I'm going to represent as 2, 2. So I'm going to write 2. The carry is going to be 2. Then I'm going to 3 times 3, that is 9, plus 2, 11. That I'm going to write as 2, 1. Carry is going to be 2. 3 times 2 is 6. 6 plus 2 is 8. 8 is 1, 3. So I'm going to write a 3 and then a 1. And I'm going to add this. This will be 1. That will be 2. 1 plus 1 is 2. 2 plus 3 is 5, which is going to be like this. We have reached the check before you go ahead slide. So I want you to know what 234 in base 5 plus 33 in base 5 is. You should be able to do addition like what we did on the previous slide. We have reached the end of the module, so please go ahead and do the review quiz.